Hello, let's continue our Sudoku adventure with Room Tour by Crusader175. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have clues outside the grid. These are called numbered room clues. So let's just pick an example like this one here. What this is this is telling us where the 1 goes in this column. And that is that placement, that index, sort of whichever row it ends up in, goes in this cell here. So let's just work backwards here. If this was a 3, for example, we would count 1, 2, 3, including itself, 1, 2, 3, and that places the clue. That places a 1 there. If this was a 4, we'd instead count 1, 2, 3, 4, and we place a 1 there. So that's important for these ones on the right, because if this was, say, a 4, we'd count 1, 2, 3, 4, we'd place a 2 there. So that's how all of these numbered room clues work. And that's it. Those are the only clues we've got. There is a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so with numbered rooms, I always think about how there's 2 digits you can't put next to a numbered room clue. The 1 is an exception. So if it's not a 1 clue, there's 2 things you can't put next to it. So let's just think about, I don't know, this touches 2 and 6, so I'm not going to think about that right now. Let's think about this 3 here. So just in isolation, this 3, we can't put a 1 next to it. Because if we try to put a 1 next to it, that's occupying the spot that we're trying to put the 3 into. So we just cannot do that. And then the other thing, which you may notice, is we cannot put itself next to itself, again, unless it's a 1, because this is saying we have another 3 right here, and we'd end up with 2 3s in the row. Or it just would be wrong, and it should have been a 1. But if it's a 1, we can't put a 3 there. So yeah, you can't put 1 or itself next to itself unless it is a 1. This can easily be a 1. It doesn't have to be. It could be a 5. We're putting 1 there, right? But it can be a 1. So other than the 1 clues, we can't put 1 or itself next to itself. Okay, so I think in addition to that, we want to think about, because this seems to be a pattern in this puzzle, what does it mean for us to have opposing clues, right? We have the 2 here and the 2 here. So these 2 cells here, let's just go through some examples. Well, this can't be a 1, because if this was a 1, then again, I just explained, you can't put a 1 next to the clue. You also can't put a 2 next to itself. If this was a 3, we count 1, 2, 3, it puts a 2 here. And then that means this 2 here needs to count 1, 2, 3, 4 and place a 4 there. Now, if this was a 4, that places the 2 here, and this would need to be a 3. I think we can probably prove that these 2 cells are going to add to 7. Because wherever this one is, this is going to be 6. So if this is n, right? If this is n, then this is going to be 6 minus n. Well, if this is a 1, this would be 7 minus n. So if you think about it, if this was a 1, this is going to be a 6. That's 7 minus 1. If this is a 2, this is going to be a 5. That's 7 minus 2. And so if this is n, this is 7 minus n. If we add 7 plus n minus n, the n's cancel out and we end up with 7. So if we add these 2 cells together, that's going to be 7. That's going to be true of all of these. These are all going to add to 7. So how do we add these 2 to 7? Well, we can't do 1, 6 because we can't put a 1 next to a 2. And we can't do 2, 5 because we can't put a 2 next to a 2. So this has to be 3, 4. All right. And so then out here, we cannot use 1, 6 or 3, 4. So this has to be 2, 5. This is also 2, 5. Now this can't be 2, 5 or 1, 6. So this is 3, 4. We end up with a bunch of 3, 4 and 2, 5 pairs all over the place. 1, 6 ends up getting filled here. Okay. Now I think we would need to use this 6 clue, because this is saying 6 is in the 3 or 4 spot. Well, we prove 6 can't go here. So we end up with 6 here with this a 3, and that resolves these pairs. And now now we know these digits, we can place it. So the 2 ends up here. That gives us the 5, 2, 2, 5. This 5 tells us 3 is here. Notice it does match the 2. This 2 tells us 3 is here. It does match the 5. And this 4 tells us 5 ends up here. It does match the 3. And I think the last thing we need to do is use this 1 clue. I bet there's a bunch of Sudoku to do, but let's think about the 1 clue. It can be next to itself. It could be here. If it were here, it would be a 2, but this cell can't be a 2. Can't be a 3. If it were a 4, it would put a 1 there, but that clashes with that 1. And it sees a 5, and if it were a 6, it would go down here, but it sees that 1. So yeah, this can only be a 1. And now it should just be Sudoku. So yeah, let's just fill these out. So 2, 3, 1, 4. So 1 and 4 go down here. This is a 1, 4 pair. This ends up then being a 6, placing this as a 5, and then this is also a 6. This 1 ends up here, giving us the 4 and the 1. These two digits are 4 and 5. This is the 5, this is the 4, because of that 4 there. Up here we need 2 and 3. That go in that order, because of that 3. Down here we need 4 and 6. This 6 tells us this is 4 and 6. Just literally just filling every digit. This 6 needs to go up here. This 6 tells us it's not there, so that's a 6. We need 5 and 3 to go down here. This is 5 and 3. This is just the remaining 2 for the box. This is our 1. Down here we need 2 and 4. They go like that, and we're done. Alrighty, neat puzzle, Crusader. I liked thinking about why these needed to add to 7. That was neat. And it makes sense. It's n plus 7 minus n. So the n's cancel and you end up with 7. That's neat. And then you also can't put 1 or itself next to the digit. So by depth, you're forced when you have opposing digits other than probably 1s. Opposing 1s might be less restrictive, but opposing anything other than a 1 is going to remove the 1 and the 6 and another pair for its own digit. So yeah, 1 and 6 don't do it, but 2, 3, 4, and 5 do. Okay, yeah, cool. That's neat to think about. Very cool property you demonstrated there, and a neat puzzle. I enjoyed it. Hope you did as well. And if you did, then why not leave a like, subscribe, and a kind comment below.